Hello everyone. Welcome once again to Academic Coordinates. This is an introductory video series. Right, for the past video we have looked at sequences, arithmetic sequences, quadratic sequences, and geometric sequences. We did all types of things. We were able to find Tn, we're able to find the common difference, the common ratio, but there is one aspect that series brings into the picture. We never did, summation of terms. We never did addition, right? So basically, series introduce us to that phenomenon, right? So series is a sum, right? A sum of any sequence of terms, right? So just take note that this is a general introduction of series. So basically, this can be arithmetic sequence or a geometric sequence, right? Okay, so basically it brings us into the summation of the terms that we might be given, right? Whether it's arithmetic or geometric. So we've got a finite series, and then this is the summation of a finite number of terms. All right? Okay, so it's a summation of a finite number of terms, and then we represent this as Sn, which is a summation of the first n terms of a sequence, right? Let's say, for example, we've got 2, 4, 6, 8, 10, right? And then from this sequence, we want the summation of the first 4 terms of the sequence. So that is going to be 2 plus 4 plus 6 plus 8, right? These are the first 4 terms. So what is this? Okay, 4 plus 6 is 10. 10 plus 8 is 18 plus 2 is 20. So the sum of the first 4 terms of this sequence is 20, right? And hence, generally, Sn will be the first term plus the second term. We're going to keep on adding, right, until we get to Tn. You know what I'm saying? And also, we do not only have finite series, but they also exist an infinite series, right? So as you guys can guess that this is a summation of an infinite number of terms, right? So we represent this by S, then there is infinity, right? So basically we've got a sequence of terms, right? So this is going to be T1 plus T2. We're going to keep on adding, until we get to, whatever term it is. So this is an infinite sequence, right, that we are adding. Hence, infinite series is a summation of an infinite number of terms, right? And also, guys, to help us in this summation phenomenon, we've got a very useful notation that is represented by this, right? This is the sigma notation. Sigma notation also assists us in summing. So it sums terms. Let me just make an example. Let's say we have got this is the sigma notation. We have got here 3n, right? So n is equals to 1. So this is the lower bound. let's say until 4. Okay, so let's say we've got something like this, for example. So what this means is that we are summing these terms in this way. So it's going to be 3 multiplied by 1. We are starting with this one, plus 3 multiplied by 2, plus 3 multiplied by 3, plus 3 multiplied by 4, right? So 4 is the upper bound. So basically, we are summing all of these terms. So this is 3 plus 6 plus 9 plus 12, right? And then what is that? So 3 plus 6 is 9. 9 plus 9 is 18. 18 plus 12, that is 30, right? So basically, the sigma notation is also useful in summing terms, right? Okay, let us just take a closer view at this sigma notation, right? Okay, so so let's say there's our sigma notation right there, and then we've got a term of a sequence here. Let me say t. Okay, let me just use the I. You see? Okay, and then we've got I is equals to 1. This is the lower bound, right? Okay, let me just use an alphabet. I is equals to, I don't know, P, right? Let's just use P until, I don't know, until what? Z? Until Z. Okay, cool. So basically what is going to happen here is that this is a summation of terms in this way. So the first term right here is going to be TP, right? And then the second term is going to be TP plus 1, right? The third term is going to be TP plus 2. Then we are going to keep on summing until we get to TZ, right? So having seen this, let us just what does it boil down to, right? So I here is the index. It's called the index of the sum, right? Okay, so basically we have got I, which is the index of the sum, and then this P, right, is the lower bound. So we are starting from P, and then this Z is the upper bound. Upper bound, right? Okay, cool. So basically the Tn there, you know, is the term of the sequence. The Ti, this is the term of the sequence, right? And another thing that is very much important, guys, is that the index here of the sum increases by steps of 1, right? So it increases by steps of 1. As you can see, this is P, then P plus 1, P plus 2, and so on and so forth, right? And so the sigma notation and, okay, let me just write it with another color. The sigma notation and the sum here, they can be used interchangeably, right? Okay, let's say we've got Bn right here from n equals to 1 until 4, for example, you know. So these can be used interchangeably to some degree, you know what I'm saying, depending on what is given, right? Okay, so but obviously this will be S4, right? So this is gonna be B1 plus B2 plus B3 plus B4. As you can see, guys, that the index, you know, of the sum here increases by 1, You know what I'm saying? So basically, this was just a brief introduction of series. Stay tuned for the next videos as we are about to dive deep into this, and you know, you'll get to appreciate series as a whole. Do stay blessed and enjoy the rest of your day.